Good morning, students. Today we are going to read in the topic of vectors, finding a vector v perpendicular to both vectors v1 and v2. So this is very important thing. So concentrate yourself. This is pure mathematics 3 A level class. So here is a question that will make your concepts more clear. Find a perpendicular vector to both vectors 3i plus j minus k and I plus 4j minus 2k. So the requirement is find a perpendicular vector to both of these vectors. So look, now the solution is very simple. I'm telling you a very simple method. So look now, I, j and k. And the first vectors, position vectors are 3, 1 and minus 1. And of second vector is 1, 4 and minus 2. Okay, determinant. So solve it now. So I into, so you will leave this row and this column. So 1 minus 1, 4 minus 2 will be left. So 1 minus 1, 4 minus 2. Okay, listen now. When you will go to the second element, you have to change the sign. So minus j. So now this column and this row will be left. So 3 minus 1 and 1 minus 2 will be in the determinant. And finally plus k. Plus k. So 3, 1, 1, 4. So now open the determinant as usual. So I into minus 2 minus, this will make minus 4, because of this will become plus 4, minus j, minus 6 minus, this is minus 1, so this is because of this minus sign it will become plus 1, and plus k, this is 12 minus 1. So now the last step, this will make 2i, this will be plus 5j, and this will be 11k. So this is the vector which is perpendicular to both of these two vectors. The next thing that we are going to read in the vectors is point on a plane. So it will be given a point and you will be required to check either the point is lying on the plane or not. So look, now here is a question that will make your concepts more clear. So verify whether the points A and B lie on the plane. So here is the plane and 2 points are given. So you are required to check either these points are lying on the plane or not. So actually we will check the dot product of the position vector of point and plane is equal to 2 or not. If that becomes equal to 2, then that point will lie on the plane. If dot product is not equal to 2, then that will not lie on the plane. So look now, the position vector of A is 1, 1, 1. Okay, first we are going to check for A. So that is 1, 1, 0. And the position vectors of plane are 1, 1, 1. So we are going to check the dot product of this one. So it is 1 ones are 1 plus 1 ones are 1 and 0 ones are 0. So this is actually making 2. So this is equal to 2. So A lie on the plane. Now for B, the same procedure will be repeated for B. B is 2 minus 1, 2. And the plane is 1, 1, 1. So 2 ones are 2. Minus ones are minus 1. And 2 ones are 2. So this is 4 minus 1, that is 3. That is not equal to 2. So B does not lie. on plane. Okay students, the next thing that we are going to read in the vectors is the line and the plane. So in this topic, you will be given a line and the plane and will be required to check whether the line is lying on the plane, parallel to the plane, or intersect the plane. And if intersect the plane, then find the point of intersection. So this is very important question, and here is a question that will make your concepts more clear about this topic. Determine whether the given lines are parallel to, contain, or intersect the plane. 2x plus y plus z is equal to 4. If they intersect, then find the position vector of their point of intersection. So look now, solution. For first part, here is the r, and r is 1 minus 2 lambda, then 1 plus 3 lambda, and then 1 plus lambda. So this is r, and this is n, that is plane, that is 2, 1, 1. So look now the concepts. If r dot n is equal to d, then it will lie on the plane. If r dot n is not equal to d, it will be parallel to the plane. The line and the plane will be parallel. And if r dot n is equal to d, that involves the equation involving lambda that will intersect. So here are three cases. So listen again. If r dot n is equal to d, then the line will lie on the plane. If r dot n is not equal to d, then the line will be parallel to plane. And if r dot n involves some equations involving lambda, then we will find the lambda. Actually, then line and plane will intersect each other, and then we will find the point of intersection. So look now, r and n are here for first part. So now we are going to find r dot n. So look now, 2 minus 4 lambda plus 1 plus 3 lambda plus 1 plus lambda. So look now, 2 plus 1 3 plus 1 4 minus 4 lambda plus 3 lambda will be minus lambda, and will be cancelled. Okay, so this is r dot n, which is equal to d. So it means this line will lie, the first part, this line will lie on the plane. So this is a case of line. Okay, the second case, here is second part. So r is 2 plus lambda, then minus 1 minus lambda, and finally 3 minus lambda. So this is r, n is same, that is 2 1 1. So now we are going to find r dot n. So 2 2s are 4, 4 plus 2 lambda plus, this will be minus, so minus 1 minus lambda, and plus 3 minus lambda. Okay. 4 minus 1 3 plus 3 6. 2 lambda, and minus lambda will be minus 2 lambda, so lambda will be cancelled. So this is equal to this, which is not equal to 4. So it means second line will be parallel to the plane. So parallel to plane. And next we are going to do the third part. In this part, r is minus 1 plus lambda, then 2 plus lambda, and finally minus 4 plus lambda. And n is still same, that is 2 1 1. So we are going to find r dot n now. So minus 2 plus 2 lambda plus 2 plus lambda minus 4 plus lambda. Okay, from here you can see minus 2 plus 2 will be cancelled and minus 4 will be left. Okay, 2 lambda plus lambda will be 4 lambda. So because this is a equation involving lambda, so now we will take it equal to d, and d is equal to 4. So this will be taken equal to 4. Okay, rest of the question will be solved here. So 4 lambda will be equal to 8, and lambda will be equal to 2. So this is the value of the lambda. So definitely the line and plane will intersect each other. Okay, now the point of intersection will be here. So this put lambda value over here. So point of intersection will, so this is the value of lambda. So to find the point of intersection, putting lambda is equal to 2 into this one. So minus 1 plus 2 will be 1. 2 plus 2 will be 4. And minus 4 plus 2 will be minus 2. So this is the point of intersection of the line and the plane. The next thing that we are going to read in the vectors is the equation of the plane when, this is case number 1, when a given point with a position vector A and the normal vector n. So a normal vector, a perpendicular vector will be given, and a position vector of a point will be given. So look now, the equation of the plane is given by x, y, z dot n is equal to a dot n, where n will be the perpendicular vector and a will be the position vector. So here is a question. Look now, that will make your concepts of this topic more clear. Find the equation of the plane containing the point with position vector. So this is position vector. So a is 2 minus 3 1. So this is a, and n will be the perpendicular vector. Okay, and having this vector perpendicular to the plane. So 1 minus 2 minus 1. So 1 minus 2 minus 1. So the equation of the plane is the requirement. So this concept will be used. So look now, x, y, z dot n is equal to a dot n. So x, y, z into n is 1 minus 2 minus 1 is equal to a. Here is a, 2 minus 3 1. Dot n, and n is 1 minus 2 minus 1. Okay, now solving it, x minus 2y minus z will be equal to 2 plus 6 minus 1. So 8 minus 1 will be 7. So x minus 2y minus z is equal to 7. This is the equation of the plane. Here is the case number 2. For finding the equation of the plane, the case number 2 is you will be given 3 points A, B and C. The procedure will be, first you will find AB vector, then BC vector. Step 2, obtain the normal vector. For example, using the cross product to get n is equal to AB cross BC. So you will find the cross product of two vectors. And finally, the equation of the plane will be xyz dot n is equal to OA dot n. So this will be the procedure when 3 points will be given and you will be required to find the equation of the plane. So look now, here is the solution of a question that will make your concepts more clear. Find the equation of the plane containing the points A, B and C. Okay, first we will find the vector AB. That will be equal to OB vector minus OA vector. So that will be equal to 3 minus 5 minus 2. Minus 2 minus 1 will be minus 3 and 0 minus 1 will be minus 1. Okay, then you will find the vector that is BC. That will be equal to OC minus OB. So look now, 2 minus 3 will be minus 1. 3 minus minus 2 will be 5. And minus 4 minus 0 will be minus 4. So this is BC vector. Okay. Then you will find the normal vector. So this is step number 2. Now you will find the normal vector. So that will be equal to, okay, look now, n is equal to AB cross BC. So that is I, J, K. There is a B vector minus 2, minus 3, minus 1. So minus 2. Minus 3, minus 1, and BC vector is minus 1, 5, and minus 4. So now solving it, so I into minus 3 minus 1, 5 minus 4, minus J. So minus 2 minus 1, minus 1 minus 4, and then plus K. That will be minus 2 minus 3 and minus 1 5. So open the determinants as usual. So I into 12 plus 5 minus J into 8 minus 1 and plus K into minus 10 minus 10 minus 3. Okay, this will be 17I minus 7J and minus 13K. So this is the normal vector. And finally, the equation of the plane will be xyz dot n is equal to OA dot n. So look now, xyz dot n is 17 minus 7 and minus 13 equal to OA. Here is A 511 dot N. N is 17 minus 7 and minus 13. So at this step you will solve it. So 17x minus 7y minus 13z will be equal to 7 5s are 35 and 85 minus 7 minus 13. So this will make 20. So will be equal to 65. So this is the equation of the plane. And now the third case, that is case number 3 of finding the equation of the plane, is in which, in this case, given two lines with vector equations. So two lines will be given with vector equations, for example R1 and R2. To find the equation of the plane in this case, the procedure will be: step 1, obtain the direction vectors B1 and B2. Those are here. Then step 2, find the normal vector by cross multiply of the B1 and B2. And finally, third step will be equation of the plane, that will be x, y, z dot n is equal to A1. A1 is here. So A1 dot n. So look now, here is a question that will make your concepts more clear. So look now. Find the equation of the plane containing the lines L1 and L2 with the respective vector equations. So these are the vector equations. So look now. B1, the direction vector of the first line is 1 1 1, and the direction vector of second line is minus 1 1 and minus 1. So these are the direction vectors. The next step will be, now we will find the normal vector, that is by cross multiply of the two direction vectors. So the method will be I, J, K. 1 1 1 will be put here, and minus 1 1 and minus 1. So now open this determinant as usual. So that will be equal to I into 1 1 1 minus 1 minus j 1 1 and minus 1 minus 1 and plus k, that will be 1 1 and minus 1 1. Now open the determinants as usual. So minus 1 minus j into minus 1 plus 1 and plus k into 1 plus 1. So from here minus 2i plus 0j and plus 2k. So this is normal vector, and the final step will be equation of the plane, that is x, y, z dot n is equal to a1 dot n. So x, y, z as it is, dot n is here minus 2 0 2. On the right hand side, a1 is 1 2 minus 1, dot n minus 2 0 2. Okay, from here solve. Minus 2x plus 0y and plus 2z equal to minus 2 plus 0 minus 2. So that will equal to minus 4. Taking minus 2 common from the left hand side and minus 2 common from the left hand side and pushing it towards right side. So x minus z will be equal to 2. So this is the equation of the plane.